Hi all, this is Amardeep Srivastava and this is the continuation of lecture series which I have started on my channel GATE UPSC Simplified. In this lecture, I have taken a question which is a previous year question of Indian Civil Services question. They have asked this question in 2006 and there are two parts of this question, first part and second part. I have started an analog electronics previous year question analysis for electrical optional. So I am taking this, this is the second part of that. Now, in this question it is given that question number 2 has two segments. Like first question is silicon diode D1, D2 in the circuit of the figure have saturation current of 1 nanoampere and 20 nanoampere respectively. That is, for saturation current for D1 is 1 nanoampere and saturation current for D2 is 20 nanoampere. And these all conditions are given at the given temperature 300 Kelvin. That you can say 27 degrees Celsius. That is the question framer is asking about the different parameters like I1, I2, B1, B2 at room temperature. They have also provided the details like Boltzmann constant K value is 1.38 into 10 to the power minus 23. Okay. And Q value is 1.6 10 to the minus 19 coulomb, as we already know this. Okay. And emission coefficient, that is eta, is equals to 1, which is for germanium, and 2 for silicon. Okay. Now, in this question, it is given that diode D1 is connected like this, diode D2 is connected like this. Let's start with the solution of the given question. So for part first, now as you can see that in the circuit itself, like let me draw the circuit again. Like D1 is connected like this, D2 is connected like this, and there is a battery of 6 volt is connected like this. Positive polarity is here, negative polarity is here. Okay. Now this is diode D1, this is diode D2. I1 is the current entering to the diode D1 and I2 is the current because of the forward conduction of diode D2, that is I2. These are the voltage polarity of the diode given V2 plus and minus V1. Now from this configuration, on looking this circuit, you can simply say that अब जो ये simple सा arrangement दे रखा है, इसमें तो आप देख के ही बता सकते हो because of the 6 volt battery source. Simply we can say that diode D1 will be in forward bias while D2 is in reverse bias. Why this configuration is that positive terminal is connected with the positive part of this diode D1 and the negative terminal is connected with the positive part of diode D2. So you can say that diode D1 will be in forward bias and diode D2 will be in reverse bias. As the question is of 5 marks, H you can write directly or you can explain a bit like as for diode D1 the positive terminal is connected to positive and for diode D2 the negative terminal is connected to negative. But if this question came in 10 marks, you can explain that question, but as the question has been fragmented to 5 or 5 marks, so you can reduce the time, you can reduce the steps because you can directly use the steps. Likewise, D1 will be in forward bias because of the arrangement and D2 will be in reverse bias by simply looking through this. Now as D1 will be in reverse bias, so you can say that D1, the current through D1, that is ID1, you can say that through the diode current equation is that I saturation 1 e to the power, the voltage across diode T1 is V1 by eta Vt minus 1. This is the basic diode equation, current for diode equation. Okay. Now as D2 is in reverse bias, so you can say that I D2, current across or current through the diode D2 will be just saturation current IS2. Simply there is no need to look over these things because this is very basic thing. The very first thing is you should know about is that this is the diode current equation when diode is conducting. When diode is in reverse bias, only saturation current will flow. Okay, now I1 is what? I1, that is this current, is what? Is the current across D1, which is equals to IS1 e to the power V1 by eta Vt minus 1, which is given as in the question you can see, silicon diode D1 D2 in the circuit of the figure have saturation current of 1 nanoampere and 20 nanoampere at 300k. So it will be 20 nanoampere. Okay, so what will be I2? Will be negative of I1. You can write this because in this circuit I1 is flowing like this and I2 will flow like this. Okay, so it will be equals to, so you can write ID2 as minus of 20 nanoampere, and it is also I2 as per written in the circuit diagram. Okay, now 20 nanoampere will be equals to IS1 is 1 nanoampere, saturation current of diode 1 into e to the power V1 by, as the diode we have taken is silicon diode, 2 Vt minus 1. So through this you can calculate the value of diode V1. What you will get is that 20 plus 1. This 20 is in nanoampere. This nanoampere will cancel out, so there is no need to write the unit here. Will be equals to e to the power V1 by 2 Vt minus 2 Vt. Taking ln both side, what you will write it here is that ln 21 is equals to V1 by 2 Vt ln E. Base of ln E is A. Okay, so what you will get here is that on further solving you will get V1 is equals to 2 Vt ln 21. This equation you will get. What is ln 21? We can solve right here. It is 3.044 multiplied by 2. You will get 6.089. What is Vt? Vt is nearly 26 millivolt, or you can take 25 millivolt. Let's take 25 millivolt, that is in volt. You will have to multiply it with 0.025. Okay, so what you will get, I have solved all the factor. You will get V1 equals to 0.1522, where I have taken Vt equals to 25 millivolt, approximated model, which is equals to Kt by Q. If you want to solve, you can solve. K is Boltzmann constant, T is the temperature, the given temperature, and Q is the charge. All the values are given. If you want, I can solve it. You will get nearly 25 millivolt of that. Okay, now V1 is calculated. So what you can write here is that from the diagram, applying KVL in the loop. So you can apply this KVL in the loop. Okay, what you will get here is that -6 plus, you will have to write, if you are writing a conventional paper, you will have to write where you are doing what, like KVL in the loop, and mention not KVL, Kirchhoff's voltage law in the loop. What you will get is that -6 plus V1 minus V2 plus V1 minus V2 will be equals to 0. From this you can write V2 as minus 6 plus V1. V1 already we have calculated in the first segment. V2 will be equals to then minus 6 plus of 0.1522 volt. What you will get here is that minus 6 plus 0.1522. You will get as minus 5.84. So V2 is minus 5.84 volt. V2 is this. So you have successfully solved V1 and V2, and you have already got the value of ID1, I1 and I2. Okay. So this is the first part of the question. If you have any doubt, you can DM me on Telegram, or also you can post any type of doubt. You can send me the doubt. I will post in the group which I have created for especially for the conventional solution. You can join by searching it on Telegram, that is @WE optional, or also I will provide the link in the description box or in the comment box. So first part is okay. Now the second question is what? They are saying that input voltage to the circuit given below is V input is 12 sin omega t. Draw the output waveform and define the circuit. Question is very simple. Like this is the voltage input. Okay, this is a DC voltage which is connected in series with diode. This is the diode given. Okay, this is the output voltage we are collecting through 3 kilo ohm resistor, and this is the current limiting resistor. Okay, now simply there is no need to do very much research on this. First you can say that if you want, likewise, so simply the circuit given is for part 2 I am solving. The circuit given is the limiting resistor, the input source, voltage input source, and there is a battery source of this polarity, that is negative to positive polarity of 3 volt. Okay, and there is a resistor at load, and there is a diode connected like this. Okay, now this is where we are collecting the V output. This is of what? 3 kilo ohm. Okay, now this is 1 kilo ohm resistor, and V input is what? 12 sine of omega t. So you can say that if this diode will conduct, let's say diode is in forward bias, let's say, or let's consider it's in reverse bias. First condition is reverse bias condition. When this diode will be in reverse bias condition, we will check the condition later, but first draw the given concern input. What we are giving input as, this is the input, like V input. Vm is what? Vm is 12. This is 12. Okay, this is minus 12. Okay, now as this output terminal is regulated, I'm considering this diode is an ideal diode because there is no internal resistance is given there. So if it will be open circuited, what you will get, if the diode is in reverse bias, what you will get as an output is that this will be open. Okay, so 1 ohm, 3 kilo ohm, this voltage input will be divided through this 2 resistor, that is on applying the voltage divider rule, V output will be equals to what? 12 sine omega t into the drop across the resistor which we are considering 3 kilo ohm as output terminal, and 3 kilo ohm plus 1 kilo ohm. It will be equals to 3 by 4 into 12 sine of omega t. You will get as 9 sine of omega t. This output you will get when when this diode will be in reverse bias. Okay, and also there will be a regulated voltage of -3 volt. There will be a obstruction of -3 volt, as this polarity is connected as like this battery minus plus in this, so it will drop down the voltage source up to what extent? Up to the extent of -3. So let me draw the output voltage waveform. Okay, so it will be like this. -3, I am considering here -3 volt V output. Output waveform is 9 sin omega naught t. Okay, so it will be like this. Let me first draw this clipped form. Like this voltage will slice down the output voltage. This battery biasing will slice down the. So you can simply see that what circuit is forming, what type of circuit you are expecting from here. Like in conventional paper, you need to write these things in little detail. Even if this question is of 5 marks, but you need to express what you are trying to say. So you need to be very much focused about what you are writing, because they can deduct marks easily. So if the V output will be greater than -3 or less -3, so what you will get? You will get as the clipped output. Okay. I'm sorry. So you will get the clipped output, else you will get the same as Vm will be, for output voltage it will be 9 volt. So you can see that this is what? This is a clipper circuit. So output voltage is not allowed to fall below -3 volt. So for the conventional part, you need to write like what you have done. Like first condition, you have taken this voltage as a reverse bias mode, this diode as in the reverse bias mode. Then you have calculated the output voltage across the given output terminal, given output load, and then you will have to draw all the details. Although this question is consists of only 5 marks, so you need to not to be very much explanatory mode, but you should explain a bit, and your presentation should be as clear as it should be, so that you will get all the marks. Like for its 10 marks question, the biggest advantage is that for an electrical or for any engineering optional, that you may get 8 marks very easily, or you may get 7 marks very easily. But for any paper except any technical paper, humanities, you cannot write this much, or you cannot write very clearly in very less steps. So this is the question number 2, asked in Indian Civil Services 2006. It is of 10 marks question. I have expressed this much. If you have any question you want me to solve, you can send me in the Telegram channel. Thank you so much.